Michael Feldstein, co-founder of Argos Education, and this is a quick demo of our design work for Argos Sojourner. This is as of June 4th, 2021. Um, just before we jump in, I'm going to give you a quick background on what this is being built on, because substantial code already exists and you can review both the code itself and what you can do with it. So the base of this is the next generation version of the Open Learning Initiative, or OLI, software from Carnegie Mellon University. If you go to oli.cmu.edu, you'll be able to see their current catalog of courses, 100% of which will be migrated over to the next generation system. And you'll be able to see the course, click in and see the courses themselves. You'll see that OLI is particularly good at mastery learning type activities, but is pretty flexible and powerful. The code base itself exists. It's working. You can find it in GitHub today under a permissive MIT open source license. If you search for OLI Taurus, Torus is the code name for this next generation project. You'll see it there. Added to that code base, ASU is migrating their substantial course catalog. If you go to inspark.education, as well as their Infiniscope project, you will see examples of courses that are migrating. InSpark is the main one, I think, that's worth looking at. It will give you a sense of both their catalog as well as allow you to get a sample of their lessons, which are very sort of hands-on, virtual lab, discovery, exploratory learning kind of code. That's all built on Smart Sparrow, which was discontinued by Pearson after acquisition. ASU got permission from Pearson to reverse engineer Smart Sparrow on a project called Janus. And that code, both the runtime as well as the authoring, is being moved into the main OLI repository. And in both cases, Carnegie Mellon and InSpark expect to have their courses all migrated over to the new system by, starting in tranches this fall and completing in next fall. So by next fall, we'll get 200,000 enrollments on a platform that supports two very different styles of courseware, with full authoring as well as delivery and analytics and so on. So that's the code base. That's all non-dilutive capital that went into the foundation for what you're about to see. We've been involved in this project from the very beginning as a paid advisor to facilitate the collaboration. We've been very involved in the architecture. Our joint venture partner, Unicon, was hired by ASU's development group to do the development of their part of the Janus project. So we know this code base very well. We have a high degree of confidence in it. What you're going to see today is what we imagine doing with that spliced DNA, what we think is possible that's new, right? So this is a conceptual demo. I'm not going to be going through all of the workflows in all detail. I'm not going to be, not all the screens are perfectly designed yet. It's really to test the value proposition. So we're going to be clicking in as if we're authors. This is a demo of authoring today. And the main scenario that we're going to focus on is adopt and adapt. And you can think of this in terms of, say, canva.com, where in Canva, if I want to go in and I want to create a book cover, or I want to create a meme, or whatever it is that I want to create, the value proposition is that I can get that done in 15 minutes and have it look really nice. And in reality, I can say this as a Canva user, sometimes I will reclaim the time that I would have spent fiddling with settings that I don't actually care about in a more traditional design program, and reinvest that time into improving the design of whatever I'm building. Other times I just want to get it done. So that's the typical faculty scenario. They're going to adopt a courseware product, and then to varying degrees they're going to adapt it, right? Just briefly touching on the other three scenarios we'll support. Assemble together, I think the common misconception is that instructors will cobble together little tiny pieces into a course of their own. There are a few instructors that do that. Sojourner will support that. It's not really our main use case. Main use case is really something that is a variation of adopt and adapt, where maybe there's a specialized course that's being developed and you want to pull a module from over here and a module from over there and put them together into a course, but you're not really putting together fine-grained pieces. The third case is a variation of that, where what you're pulling in might not actually be courseware modules, it might be content. You know, you could be teaching nursing and have, or history or political science, where you have a lot of primary sources or scholarly articles that are the readings. You might be teaching English comp, but what you have is or you might have maybe an OER EPUB that is a complete textbook that was created, but it's a textbook really. And what you want to do is import that content and then use both UI design cues as well as AI and ML to develop learning objectives, to create assessments, to essentially turn this into that content into modern courseware. That's a scenario we're very excited about. It's not the topic of today's demo. And finally, we expect there will be a handful of faculty, but more importantly, design shops, whether they're university shops that are building MOOCs or online degree programs today, or OPMs, or other third-party enablers that will want to build courses from scratch. So those are the four scenarios that we support. We're going to dig into adopt and adapt, right? So the first thing that we do, and we're doing a lot of user research right now and have a lot more planned about really what information we can gather from instructors to help them speed their adopt and adapt. What can we find out about them that will help us make good recommendations for them? So let's just say, and these are all optional and they're likely to change as our user experience research grows, but let's just make some choices here. We're going to teach in English. Students are generally on level. We would say $50 or less is what we're going for. And then, of course, I want to know what you teach. You teach chemistry. And based on that, you're brought to what is a marketplace. Now, the marketplace will have smaller pieces. You might select, for example, right now it's showing full course because you're adopting, and then you're going to adapt. But if you wanted to add labware, for example, virtual labs, you could search for that asset type too and add it. We're focusing on selecting that base text that or the base courseware product that you're going to adopt and adapt. And we'll choose today OpenStack's chemistry, Adam's first 2E. So this is a courseware product that was built out of the OpenStack's OER product. We see the dollar figure for how much it's going to cost students in another demo with a fully fleshed out store. We have a shopping cart that shows instructors as they add pieces what the total cost is going to be to the students. And we'll improve the data here that's shown. For example, we expect to get platform data about efficacy. We expect to get platform data about accessibility of the content, right? We can display all of that here. So let's say the instructor clicks in and they see, this is essentially the product, and we don't, this is just a mock-up, right? So, but in the, we have a preview mode already working in the code. You could actually preview this entire courseware product if you wanted to as an instructor. We have a nod towards that, that second category of putting together pieces. But for now, we're just going to use this course. We're going to pick this and, just given a chance to review what I've picked and change my selection if I want. But I'm going to go ahead and call this my chemistry course. And, that carries through. And now I may be creating this course with a team of reviewers or editors or viewers. It might be that we're creating this chemistry course for our entire department and the various faculty want to be involved. Maybe we want to pull in a learning designer for the Center for Teaching and Learning. Maybe this is being created by the Center for Teaching or Learning, or whatever center inside the university creates MOOCs and online programs. Or maybe it's a professional team, an OPM, an OPE, some other type of content shop that is creating the content by team. So we've adopted the Google conventions here to make it seem familiar to folks. We're going to share with the team and we're going to continue. Now this is where things get really interesting. What we're trying to do here, and this is, again, we'll do a lot more in this area. This is an early demonstration that we will refine. But what we're trying to do is help the instructor visualize the pedagogical structure of what they've just adopted. So we have the entire course outline here laid out of the course we've adopted. We can see which subsection or which unit we're on, and these are the 3 lessons that are pulled from this particular unit of this particular OpenStax course. There's precipitation reactions and solubility rules, acid-base reactions, oxidation reduction, and oxidation reduction reactions. And it turns out, if you look closely at these OpenStax texts, which we have, they follow a particular pedagogical pattern, right? We're calling this pattern, at least for now, directive instruction. They'll introduce a concept and maybe review some prerequisites. They'll develop the concept. They'll give some guided practice. They'll reiterate. They might give some independent practice, some sort of back of chapter questions, and then there might be an assessment. And you'll see that we're calling out what we call learning loops, right? And what kind of learning loops they are. A learning loop or a learning feedback loop is simply something that the student does that tells the student and the instructor something about how well the student is learning, or what state the student is at. Could be formative, could be summative, could be somewhere in between, right? And it could be as simple as a multiple choice question, or it could be as rich as an immersive simulation. But we're calling out for the instructor, this is the structure of what you've of the lessons in the course that you've picked out. Now maybe they're fine with that. Maybe they want to know, well, what is learning objective 1? Well, we can pull out the learning objectives here. We haven't really dived directly into the learning objectives for the instructor because in an adopt and adapt flow, they really want to get done quickly. But if they want to go and review what are these learning objectives, they can do that. If they want to get into more detail, right, this becomes more important as they do more authoring, right? They can go in, they can edit each one of these learning objectives. They can decide to turn some off, and as the system develops smarts, it will also highlight what content that they are, taking that is related to those learning objectives, so they can make their own decisions. They can add their own learning objectives, and increasingly using first ML and eventually AI, will begin to suggest other learning objective possibilities. Here are some learning objectives that other instructors have used with this particular chemistry courseware product. Here are some learning objectives that instructors have used with similar chemistry courseware products. Here are some learning objectives generated by AI using NLP techniques to extract objectives from the content itself, right? So again, if I'm adopting and adapting, I don't really care about all that too much. So I only see that when I want to. I might wonder what are these colors and what are these sequences? Like what is directive instruction, right? So we have these are really, again, teaching patterns that we see in courseware products that we have templatized. So we've taken both the structure, a pedagogical structure that helps them understand what's going on in each piece, or author what's going on, or edit what's going on in each piece, help them understand how that works in a pedagogical sequence. And if they want to build their own, we scaffold that. So we'll see a little bit more of that later in this demo. But I see these sequences, I see they're all the same. I see there isn't a whole lot of practice. So one thing I might do is go in and create more practice problems. And there's a whole rabbit hole we could go down, which we won't today, about question pools and how they can add their own questions or find others that already exist. But what I want to do today instead is I want to add something a little bit, spice this up with something a little bit more interesting. So rather than the textbook directive instruction, I want to add a guided inquiry. And I'll give it a name. Let's call this, experiment. And I am going to then, there are a couple different ways to click into this, but, generally speaking, what we want to do is go from the template, the teaching template, to the storyboard, right? The storyboard is now giving me screen by screen that teaching template. If I were opening up one of those teaching templates that were already in the book, I would see the content pre-populated. But since I'm creating a new one, I'm getting this guidance from our sidebar. This is another rich area that we expect to enhance quite a bit. It's going to guide me through what I can do and what I should be thinking about as I create an explore and explain activity. Explore and explain, or predict, observe, explain, is basically your classic lab sequence. So what would happen if I dropped a feather and a rock on the moon? Which one would hit the ground first? First, I ask the students to make a prediction. Then I might show them a video of an astronaut dropping those things on the moon. And then I might ask them to explain the differences between what they expected to see and what they saw. Or if they saw what they expected to see, to explain why that's the case, right? Classic, you do this with any sort of chemistry or physics lab, any kind of, guided experiential learning, right? So, I would start off by, giving them, all this is editable, right? So I'm supposed to be helping them anticipate findings. So I'm going to tell them what this is and have them predict their findings here. Predict your findings. And students will then write in here what they expect to see. We can, because of the capabilities of the platform, we can carry this forward to a future screen and show the students what they've learned, right? So then how do I want to have them do something to observe, right? So maybe I'll show them a video in this case and have them do a lab simulation, right? What's interesting here, or one of the things that's interesting here, is if you looked at that inspark.education site that I showed you, there are quite a few virtual labs, all of which will run natively on this platform. You can author your own, and in a future demo, future version of this demo, there'll be a button up here for the experiential learning authoring studio. It's a much more complex authoring environment. Most instructors won't want to get into it. A few and many professional learning designers will, because they can do some really sophisticated stuff in here. But the point is, you can both create your own very sophisticated experiential learning capability, because there's basically a full business rules engine behind this that allows you to write pedagogical rules that drive your simulation. Or you can also, if you want to use Labster or something like that, we allow integrations for just about any tool that you can plug into an LMS. We have full LTI support in that regard. So, okay, you've predicted, you've observed, now you want to explain, right? We'll give you some text, we'll give you some writing, we'll do all that, right? And then what I really want to do is I want to check your understanding in a way that allows the machine to give us some insight. I want a machine accessible question, right? So in this case, I'll again give some introduction tests, and I'll do a knowledge check, right? And this happens to pull up a multiple choice question. Again, we'll enrich the question types as we go. There are already a handful of assessment types that are available in the working system, and we will add more. And this happens, again, to be a multiple choice question. I can select which is right and which is wrong. Again, pulling from that studio, which I could use if I wanted to author those full-on, labs. We've actually taken some of the smarts behind that engine and implemented it into this basic environment. So if I'm an instructor, I decide I want to spend more than 15 minutes on adopt and adapt. I want to drill down and do something a little more interesting, right? I've had the students do the predict, observe, explain. I've just authored that real quickly. And if they're not making the right guess, if they guess that the rock is going to land on the moon, hit the ground on the moon faster than the feather, that indicates a particular misconception, that it's the weight rather than the air resistance that drives the speed at which the object falls, right? So I might want to do some selective branching here. I might pick a distractor that reveals a particular misconception, and then I want to do something. And this is a menu that, again, we can enrich as we go. We can have it send them to an additional bit of content, a video, another lab for them to try some more things out. Maybe we want them to keep messing around until they get an answer, right? Maybe we just want to give them feedback. We can make these choices. So what we're doing is we're taking a very flexible rules engine. We're identifying pedagogical patterns, large or small, in which we might want to have conditional branching. We're identifying those conditions, making it easier for the instructor based on pedagogical motivation rather than settings in a low-level functional authoring system, about the kind of branching that they might want to do, which they would translate as, how do I respond to a student with this particular misconception? And then we allow them to do that really quickly, in far less time than it's taking me to actually explain the functionality. They could have already done this. So that is basically the demo for today of Argos Sojourner. Obviously we'll be building out more as we go. The system already has the ability to preview a course, the actual working code. We haven't built that out. Our mock-ups haven't caught up with the actual functionality yet. So instructors would be able to preview and so on. And you can see probably a number of areas where we can branch out. But hopefully this gives you an idea today of how we think Sojourner is different, how it guides instructors to be more literate and more empowered in how they deliver seamless instructional experiences. It empowers power users. It empowers casual users who are under a lot of time pressure. Um, and it just makes learning experience design better, faster, um, and more engaging.